In this video, let's see an explicit formula to find the inverse of a non-singular matrix A. The inverse A inverse will be adjoint of A divided by determinant of A. We already know that non-square matrix will not have an inverse. So always only for a square matrix we can find the inverse. And we also know that the inverse of A will be B provided AB equal to BA is equal to the identity matrix IN. Now for the second method, let us talk about the minors and cofactors of a square matrix. The minor of a matrix is obtained by deleting the corresponding row and column. For example, if we are trying to find the minor for the entry Aij, then you have to delete the corresponding row and column. For example, if I have a matrix, say A is given like this, then if I am trying to find the cofactor, first I have to find the minor. The minor is obtained by deleting the corresponding row and column. For M22, I have to delete the second row, second column. If I am talking about M21, I have to delete the second row, first column. Then the correspondingCij's can be obtained by multiplying by -1 to the I plus j. So for C11, the first row will be, the first sign will be positive, negative, positive, negative, positive, negative, like that it goes on. Now let's see how to find a minor and cofactor of a given matrix. Say the matrix is 0, 2, 1, 3, -1, 2, 4, 0, 1. Now, in order to find the minor M11, the first row, first column should be deleted, and you have to take the determinant of that corresponding matrix 1, 2, 0, 1, which is -1. So your M11 is -1. If I'm looking for the cofactor, then I have to multiply that by -1 to the I plus j, because Cij is -1 to the I plus j multiplied by Mij. So you can get the corresponding C11, C12, C13, etc. by multiplying those Mij's by -1 to the I plus j. Once when you get the cofactors, it is easy for us to find the determinants, because the determinant is the each entry multiplied by its cofactor, each entry multiplied by its cofactor. You can expand it along the row or along the column. If you are expanding it along the ith row, you will have the corresponding multiplication by the corresponding cofactors. You can also multiply and expand it along the jth column. So you can either find the determinant using the column factor or the row. Now the determinant of this matrix A will be obtained easily. Now I would like to expand this using the third column, because the third column, 3 entries are 0 and I have only 1, 3. So if I'm expanding that using the third column, then the corresponding Aij is 3 multiplied by deleting that column and row, the remaining will be my C13. For the next entry 0, the cofactor will be C23. Then again 0 times C33, 0 times 43. So it is just 3C13, so I can find just the cofactor C13 by deleting the first row and third column of A13. And you can simplify that result and get the adjoint. So the adjoint will be nothing but the transpose of this matrix of cofactors. The adjoint of a matrix is the transpose of the matrix of cofactors. So since I have the matrix of cofactors as C11, C12, etc., the transpose will be just changing the rows to columns and columns to rows. That will be your adjoint matrix. So now since I have the adjoint matrix, it is easy for me to find the inverse of a matrix. Let's try for a problem here. So if a matrix A is given, then easily I can find the determinant, and the determinant is 3. You can easily get that result. Now for C11, that is the cofactor C11, first I have to find the minor by deleting the corresponding first row and first column and multiplying that by -1 to the 1 plus 1. 1 plus 1 is 2, so I get C11 as 4. The same way I can get C2, C33, etc. And the cofactor matrix can be obtained. I have to take the transpose of this to take the adjoint. So when I take the transpose, the adjoint becomes, the row becomes column, column becomes row, and that is my adjoint of a matrix. When I divide that adjoint by the determinant of the matrix, which I already got as 1 to 3, so when I divide by 3, that result, the final result will be the inverse of a matrix. So we can also find the inverse of a matrix using the determinant A and the adjoint of the matrix A. Hope this video is helpful to understand how to get the inverse of a matrix. Thank you for listening.